So this is my Project H quadrotor. The idea of this is to be made out of as much carbon fibre as possible, to make it as light as possible, and to use efficient motors that can run on 18650 batteries, like the battery packs that I made using Panasonic batteries, so that I can get flight times over an hour, even up to 2 hours if the payload is very light, like for example just an FPV camera that's basically no payload, so you could be flying FPV for like an hour and a half, for example. But also this will be good for cinematography, because then you could double the time that you can shoot videos to like 40 minutes instead of 20 minutes. So that's eventually what this is for. So about the components I've chosen, bearing in mind that this is a low cost carbon fibre build, which is kind of an oxymoron because carbon fibre is expensive. I've gone for these cheap Chinese motors and propellers, and the ESCs, the RC timer. So it's all RC timer. You can see the motors. They're not the most efficient, but they're pancake style, which means they are quite good. They can run off the 18650 batteries, and you can get better ones from places like T-Motor. They have much more expensive, about $50 each for the motors, but they're more efficient, and they even go up to a few $100s each. Squeaky floor. So I've bought these tubes and plates from Tarot. They're very cheap, Chinese, good decent carbon fibre. And the problem with carbon fibre is when it comes to making joints. So for the motors and for connecting this H configuration, that's why it's called Project H. This is good because it fits a payload in the middle easily. That's why H is a good shape. It's also easy to carry, you can just grab it. The problem is carbon fibre joints, they don't really work. I've used the Tarot vibration dampener things. They're good for the center. The problem is they just wobble too much on the edge, so, and these aren't very good either. It's too difficult to make by hand carbon fibre pieces that let's show you, that are just precise enough for screws and things like that, and their alignment. So 3D printing is best, but I can't afford that either, so I've got a solution I'm going to show you. So since I can't afford a 3D printer and I need to reinforce these joints, I figured out I can put the tube over it. So I've taken a plastic bottle, cut it, and this is going to go over the joint. So I have to pull this out, put a hole in here, slide this on, and then put that back in and heat shrink this with the heat shrink gun. Hopefully that will improve the rigidity. If not, I can use even aluminium cans and some zip ties. That might work. So we just go over the design of this build. The joints need to be improved, the motors could be more efficient, the motor mounts, I want them to be slanted to improve the stability, that again 3D printed, and this will be you can just grab it with your hand. These will be servo actuated so that they can pull up, although I'm not sure about how it's going to go with the propellers, because these are intentionally inverted. That's more efficient because it's not hitting the mount, the booms. And then these ESCs, there's going to be a bigger plate in the middle, carbon fibre, about 1.5 millimeters or 1 millimeter thick, probably 1 millimeter. That's going to mount everything from the ESCs flat on top, and the flight computer, and the servos for the legs, and the FPV system, and the battery for that, all on top. And then underneath is going to be a mount. The batteries will go there in a kind of tray on that mount with some spacers, and then underneath will be a gimbal mount, and the gimbal will be hanging out just about here. So It'll be quite a nice system when it's finished. It just needs more money basically. I should also point out another thing I plan to do is put quick release mechanisms on these motors, because right now I have to use an Allen key and that takes a while to undo. And these aren't very secure, these are just screws, so it's better to get the quick release. They basically rotate on in the opposite direction that these rotate when they're powered, so they won't come off basically. They self-tighten, so that's another upgrade, and those only cost about $1 or $2. But the idea, I also wanted to reduce the amount of components as much as possible, so that's tricky. Needs good designing.